Yes. So, Srikal students, so let's start chapter number 5, laws of motion. Well, class 11th. So students, first of all, we will discuss what is force. So, simple definition of force is it's an external agent. It's a push or pull which either causes motion or stops motion or it tries to cause motion or stop motion. Well, if a person is trying to push a wall, obviously he's not able to move the wall, but he's at least trying to push it. So the try word is very important in the definition of force. So we can say force is external agent, which pushes, pulls, so that it creates a motion or tries to create a motion or tries to retard the motion. Well, it's not always important that the force should be touching an object in order to stop or cause a motion. Force could be applied from a distance also without touching. But there are external agencies like gravitational and magnetic forces which can exert the force on a body even from a distance. Well, you can see under the ambit of the earth, wherever the gravitational pull of earth is there, even at distance, it can pull the objects towards its center. Same is a case of magnetic forces. They repel and they attract each other. Now, question is the external force required to keep the body in uniform motion? Is it required? So, first of all, we'll discuss about Aristotle's fallacy, right? Well, fallacy where he fell, where it came short of the proof. Aristotelian law of motion may be phrased thus: an external force is required to keep a body in motion. Well, it's not always true. It may be true. Uh, it's not always true. Well, here you see that students, if there is a ball, if ball is rotating on a frictionless plane, let's say the plane is horizontal, right? The ball will continue to move. It stops after some time. Yes, we do see it stops. Why it stops? Because of the friction between the ball and the surface, because of the air drag acting in the opposite direction. Air drag means the velocity of air trying to stop the motion of the rolling ball. Otherwise, it will continue to roll till infinity if there is no friction between the surface of the ball and the surface of the surface on which it's rolling, and if there is no viscous. So Aristotle view had a shortcoming in this. Actually the external force is really not required for the body to be in motion. So these observations gave understanding of inertia, right? Now, before even studying inertia, let's study what is law of inertia. So it was Galileo, in the starting he observed, what is this? Let's see, this small simple three experiments. This is uh, a plane with the positive slope, plane with a negative slope, and plane with zero slope. Horizontal plane, ball coming down, ball, uh, yes, here also the ball is coming down, but then after coming down, it's going up. What he observed, whenever the object is moving down an inclined plane, these are inclined planes, it will accelerate always. Whenever a project is coming down an inclined plane like this, it will accelerate from here to here if it is coming. And whenever it is moving up, it will retard. Retardation means negative acceleration. The velocity will be decreased. Finally, it will become zero. Fine. Second observation. Third observation, motion on a horizontal plane is an intermediate situation. Intermediate between these two situations. Okay. It's neither accelerating nor retarding. So Galileo concluded that object moving on a frictionless horizontal plane must neither have acceleration nor retardation. They don't have retardation, they don't have acceleration. Then it should move with constant velocity. Now, this is the observation which is contrary to the Aristotle's doctrines. Well, he said that external force is required to keep a body in motion, right? So if it is horizontal surface, Galileo observed it must continue to move. There came the difference. Let's go further. Now see students, again these double inclined planes, Galileo repeatedly did the experiments and made some observations, right? Well, this is the first experiment. You see, what he observed that this is a plane which is inclined at 2 points. You know, the ball is coming down, it will roll. Imagine the ball is, this plane is as frictionless as possible. Ball is coming down, it will run on this, and then it will try to reach almost same height from which it was dropped. Number two, if we decrease the slope of the plane, this plane slope is more than this plane, second one. The, the slope is decreased. Now the ball will again reach to same height, but the distance traveled by the ball is more as compared to distance traveled in first case. Third case, when the ball is coming down and let's say again the plane is frictionless, the ball will continue to move. It doesn't require any force, contrary to what Aristotle believed, that the force is required when the ball needs to be in motion even on a frictionless plane. Law of inertia was inferred from these observations, why the ball has tendency to go up, why the ball is having tendency to go up even if the this slope was decreased, even if it's traveling more distance, still it has tendency to reach the same height. One more observation from this experiment: in no case the ball will never, suppose this is the height from which the ball was dropped, let me show you. This is the height from which the ball was dropped. In no case, students, the ball will never uh, the ball will never the height will never be increased. It will remain the same height. So this is another observation we made. All right, so after the students, uh, you see that what is inertia? Inertia was defined. So you see that we always observe that uh, a body is in rest, you know, uh, it's difficult to move the body. You have to apply more force. When the body is in motion, you don't have to apply so much force to put the body in motion. Okay. So this is inertia. So basically, what is inertia? It's written. It's an inherent property of all the bodies. Inertia, by virtue of which they cannot change by themselves what their state of rest or the state of uniform motion along a straight line. You need to really remember these and understand these. You know, it's an inherent property of all bodies. So, body is in motion, it will continue to be in motion. You know, if body is at rest, it wants to be continue to be in the state of rest. So we have inertia of motion, inertia of rest, and inertia of direction also. If a body isn't going in same direction, it will continue to move in the same direction unless it is compelled by some force to change its direction. So we have inertia of rest, inertia of motion, and inertia of direction. Okay, students. After having studied all this, now let's study what is linear momentum. All right, students. Linear momentum. So once again, so guys, you see that linear momentum of a body is basically the product of mass of the body and its velocity. Linear momentum. Rather simple, not so difficult. Well, it's a vector quantity. Linear momentum is basically product of mass and its
Mass into velocity.
mass times velocity. P is equal to mv. So what will be the Units of momentum, so it will be kg meter per second is the unit of momentum, right? So we can always say, students, P is equal to mv. Well, mass is constant, so you know we need not think of dot product or vector product because both are not vectors. Mass is constant, so constant into vector. Fine. Now, students, in CGS it has a unit of gram centimeter per second. In SI system it has a unit of kg meter per second. Okay, what is the dimensional formula of momentum? Well, this is kg is m, and meter per second L t minus 1, mlt minus 1 will be the dimensional formula of momentum. All right. So, guys, you see that as we observe that p vector p is equal to m vector v. So, from this, we have two observations. When m is constant, if m is constant, we can see that p is directly proportional to velocity. Am I right? So, how can we represent it? M is constant, p is directly proportional to velocity. M constant. We know that, we have learned in 9th and 10th standard. This thing shows a linear relationship between momentum and the velocity. All right, guys. Number two, see that when v is constant, when velocity is constant, so we can say momentum directly is directly proportional to m. Velocity is constant. All right. So how can we represent it? We can represent it like this. On y-axis, we can take momentum. Here we can take mass. So it is directly proportional to velocity. Well, it's a straight line. I'm not able to show straight line. It's a straight line. All right. Third case, students, when two bodies of unequal masses, two bodies, m1 and m2. M1 is not equal to m2. All right. Now, there are two bodies. Their masses are not equal, and they have same linear momentum. They have same linear momentum. What does that mean? P1 is equal to S sigma P2. So what do you infer from this? That is M1 V1 is equal to
M2 V2.
M2 V2. Okay, from this, what can you infer? V2 by V1 is equal to M1.
M1 upon
M1
M2.
by M2.
M1 M2. Okay. So what do you understand from this? The velocities of these bodies having equal linear momenta vary inversely as their masses. What does that mean? The heavier body will have, let's say, M2 is greater than M1. Okay. So if M2 is greater than M1, what do you understand from this? M2 is greater than M1. So whether V1 will also be greater than V2 or V1 will be smaller than V2 to make the product constant. Anyone? If M2, see, M1 V1 is equal to M2 V2. M2 is more than M1. If V2 is also more than V1, obviously this product will be more. So V2 would be less than V1. Am I right? So this is very important. So you see that the third graph can be shown as, this is your mass, this is your velocity. You see that, students, this is how you will show what is constant here. Your momentum is your constant. You can take some values of and let's say you can take first value of velocity v1 is equal to 5, meter per second, and you can take it as maybe, you know, 8 meter per second, that is v2. So obviously, let's say the momentum is 40 kilogram meter per second. So obviously, students, you can guess what will be m1 and m2. So m1 will be 8 kg and m2 will be 5 kg. This justifies whatever we have discussed. So if you draw, you will get a curve like this, right? Okay. Now, students, another thing. If you consider the effect of force on motion, there's always effect of force on the motion. The linear momentum is very important. Fine. See, what can be this can be understood by the following examples. You see, first example. See, students, greater force is required to push a truck than a car to bring them to the same speed in the same time. I repeat, you have a big truck and you have a small car. So you want, after some time, their speed to be same. Means v1 should be equal to v2. But you know that m1 is greater than m2. So this, from which what can be inferred? Whatever force you have to apply on m1 will be far greater than the force you have to apply on second object, right? So greater opposing force is also needed to stop a heavier body than a light body in the same time when they're moving with the same velocity. This is also with the effect of momentum. Am I right? So one more important thing I want to tell you: mass of the body is important parameter that determines the effect of force on its motion. Mass is equally important. Okay. Number two, yes, students. Now, speed is another important parameter to consider. Now, if you fire a bullet from the gun, see the small, the bullet is having how much small mass? Very, very small mass, but the velocity is considerably very high. As a result, the momentum is so high it can even pierce a wooden block. It can even pierce a sandbag. Obviously, it cannot cross a sandbag. That is all because of the second law of motion we'll be discussing again. But it can still pierce, you know, harder objects. Even iron sheets also it can pierce, right? So same bullet which is thrown with moderate speed can be easily stopped, but you cannot stop a bullet. So momentum is very important. So students, this is just an introduction to my laws of motion, right? And tomorrow's lecture will be covering first law as well as second law of motion. You know very well, first law defines force, second law helps us to do the measurement of force. How? Let's see tomorrow. Wish you all the best. Have a nice time, students.